Hello, my name is Clifford Cho, and I will be presenting our work on behalf of our research fellow, Dr. Amy Felstead. There's been long-standing interest in the possibility that conventional thermal tumor ablation, as shown in panel A, may be capable of unleashing tumor-directed immune responses. We've recently observed that the non-thermal focused ultrasound modality histotripsy triggers a cascade of events that begins with the release of danger signals like calreticulin, as shown in panel B, and resulting in a profound infiltration of CD8-positive T cells, as shown in panel C. This culminates in the stimulation of systemic anti-tumor immune responses capable of exerting abscopal inhibition of distant metastases, as shown in panel A, and enhancing the efficacy of checkpoint inhibition immunotherapy, as shown in panel B. As shown in panel C, the magnitude of this effect seems to be larger than that of traditional tumor-directed therapies like radiation or radiofrequency ablation. So these preliminary findings motivated us to test the hypothesis that the non-thermal nature of histotripsy may be necessary for optimal stimulation of anti-tumor immune responses. To test this hypothesis, we compared two modalities of focused ultrasound ablation. Thermal focused ultrasound ablation, or TFUS, uses high-duty cycle or continuous waves to generate acoustic energy converted by tissues into heat that induces thermal cell death. In contrast, histotripsy, or HT, uses very low-duty cycles, generating rapidly expanding and contracting bubble clouds that mechanically fractionate cells without heat, and some of the parameters that we use for both modalities are shown here. So to compare their effects on local and abscopal immune responses, we inoculated immunocompetent black 6 mice with bilateral B16 melanoma tumors and then treated them with either no therapy or partial ablation of unilateral tumors with either TFUS or HT, and then we followed tumor growth and flow cytometric analysis of tumor-infiltrating lymphocyte populations. As shown on the tumor growth curves on the left, TFUS and HT were comparable in terms of their ability to inhibit tumor growth after partial tumor ablation. As shown in the tumor growth curves on the right, however, only histotripsy resulted in significant abscopal inhibition of contralateral untreated tumor growth. Now, TIL analyses performed 10 days after treatment showed that both modalities induced upregulated infiltration of CD8-positive T cells and dendritic cells at both treated and untreated tumor sites. However, only histotripsy resulted in significant influx of natural killer cells at both treated and untreated tumors. Furthermore, only histotripsy resulted in influx of CD4-positive T cells as well as inflammatory neutrophils and macrophages that were particularly impressive at the treated tumor sites. Now, to compare the ability of these modalities to preserve tumor immunogenicity, we treated melanoma tumors with either TFUS or HT and then excised the liquefied tumors and introduced them to tumor antigen-specific CD8-positive T cells in vitro. As shown in these flow cytometric data, only histotripsy treatment was capable of generating tumor lysates that could stimulate tumor antigen-specific CD8-positive T cells in vitro, as shown by expression of interferon gamma. Now, importantly, the absence of T cell stimulation from lysates of tumors that didn't express the cognate antigen, in this case GP33, confirmed the antigenic specificity of this phenomenon. And then finally, we tested the ability of these lysates to function as immunoprotective vaccines by injecting them into naive mice who were then challenged with melanoma tumors. And as you can see, in contrast to lysates generated by either radiation or thermal dissociation with freeze-thaw, only tumor lysates generated by histotripsy could function as vaccines inhibiting challenged tumor growth. And then when we looked at the TIL populations of these tumors, we found that tumors in mice that had received histotripsy-generated lysates showed the same pattern of inflammatory and immune cells that we observed in mice who were directly treated with histotripsy. So in summary, non-thermal histotripsy induces a stronger abscopal immune response than thermal-focused ultrasound ablation. Histotripsy triggers a stronger influx of neutrophils, macrophages, and NK cells, and preserves the immunogenicity of tumor antigens. And finally, lysates generated by histotripsy can function as immunoprotective vaccines, recapitulating the same intratumoral changes that characterize the abscopal effect of histotripsy. We conclude that the absence of denaturing heat or ionizing radiation may underlie the unusual potency of histotripsy immune stimulation. We're presently characterizing the immunogenic cell death pathways triggered by histotripsy and are optimizing the means by which histotripsy tumor lysates could be used as personalized cancer vaccines. Thank you.